Okay, so at this point you're going to need your graphing calculator. So whether you use one of the schools or you have your own, if you need to ask the substitute to go get it, go ahead and pause this video and please go get your graphing calculator. Okay, so hopefully now you've got your graphing calculator and you're ready to rock. The first thing we need to do is set it up. Especially some of you have brand new graphing calculators. Your diagnostic is probably not turned on. I think they default to off. So we're going to do a couple steps here just to make sure that our calculators are set up and ready to roll. So the first thing I want you to do is hit your Y equals button that's in the upper left corner and check to make sure all these lines of functions are cleared out. So that Y1, Y2, all Y3, all of those are clear and there's no information in them, or they could conflict with the data in our table. Next, I want you to go hit second Y equals, so stat plot, and double check that you can turn plot 1 on just by hitting enter, and then just checking that the type is the discrete dots. It's the very first one. And that your X list and Y list is L1 and L2. I don't know why they wouldn't be because we haven't really messed with that, but we did change the type around a couple times just to try and get some continuous lines. But make sure it's on discrete dots. X list is L1, Y list is L2. Now from here, you can just hit second quit and you're back to your main screen. The next thing I want you to do for setting this up is to hit second 0, because that will set up and give you your catalog. And then here you can just arrow down, hit enter, down arrow, down arrow, down arrow, down arrow till you get down into the D section, or you can hit alpha X to the -1 button. And sometimes I have to do it twice. I don't know why it works only the second time, but I hit alpha X to the -1, alpha X to the -1. It drops me down to the D section. So the alpha is to trigger the letter D. And so now that I'm in the D section, I can arrow down to diagnostic on. It's like one long word. And hit enter, enter. And then it'll say done. And so your diagnostic will be turned on, and you're going to need that for it to calculate the line of best fit. Okay, so we should be pretty much set up and ready to roll. Go ahead and hit stat. Then hit enter, because that's your edit button. You're going to edit this list. If you still have data in this table from other things we've done earlier in the school year, go ahead and arrow up to L1, hit clear and enter, and it should clear out the data in the L1 table. Arrow over to L2, up to L so that your L2 is highlighted. Again, hit clear, enter, and it should clear any data in your L2 table. Now, if L1 and L2 columns are missing, either or both, or if you accidentally delete them as you're working, you can simply just hit stat, arrow down to setup editor, and hit enter, enter. So that was your 5th choice there. And now if you go back to stat, edit, you'll see that your L1 and L2 is back. All right, now at this point, you are ready to enter data into your table. So we want to look at examples, and number 1, you're looking at the latitude and the temperature. Which one of those do you believe would be the L1? So it would be the latitude, will be all your X values. So you're going to enter 0, enter 10, enter 20, enter, and you need to enter in all the data. You can't just like enter in like the first 5 data points and call it good. I've run into this problem before where you have to, because it's going to average all of the data, and so if you don't give it all the data to average, you'll end up having a problem. And now I've gotten all the way up to 80, so now I'm going to enter in my temperature. And so I'm going to enter in 79, 81, 79, 68, 58. So by just looking at this, you should be able to tell that there's going to be a negative correlation because the temperature is dropping as x is increasing and the latitude is increasing, the temperature y is decreasing. Okay? All right, now, what do we do with this information? Well, we're not going to graph it. Once you have your L1 and L2 information into your table, you're now going to go up and look at the calculator steps, find the line of best fit. Hit Stat, arrow to the right, over to Calc, and then all the way down to 4. You can either actually just type the number 4, or you can just arrow down 4 times what I do. And then hit Enter, and then hit Enter, 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 Enter. So you get down to Calculate, and eventually it'll give you this weird looking thing that says lin reg, y equals ax plus b, and then it will tell you that a equals negative 1.07166666, and it could just keep going on. So eventually it just estimates to 7, so to cut it off. So to find the line of best fit, your equation is actually y equals negative 1.07, I'll just leave it there at the hundredths place, x plus b, which is 92.87. So if you're looking at that, it just gave you the y equals ax plus b. Your a, oops, put my pen on here. Y equals ax, so negative 1.07 is a, x plus b, which is 92.8, and I'll round it to 7. So what does this mean? Well, remember, what is our y-intercept? Our y-intercept is where does the line start? So even though our highest temperature data point is 80, it's saying that with this data information, sorry, that's x values. Our highest temperature is 81. It's saying that our starting point is 92.87. I know that sounds ridiculous, right? But that's what it is. So you might think to yourself, well, how in the world does that work? How can I have a y-intercept that's higher? I thought we were averaging, Mrs. Evans. How come I don't have one? When you start to see these graphs, you'll kind of understand better. But you're averaging all of the data in the middle. So it's possible that the end point is sticking up higher than you would expect. And it'll look more obvious when you actually see the graphs. But for now, we're just dealing with, this is what the computer calculated, the calculator calculated, so we're just going to stick with it. So now to find the average temperature for a city with a latitude of 48, what would you stick this in for? Does this 48 go in for y, or does this 48 go in for x? We said latitude was our x value. So therefore, we're going to redo this equation, y equals negative 1.07 times 48, just plugging in our input, plus 92.87. And now we can calculate what the what the temperature would be with a latitude of 48 degrees. Okay? So we're going to come over here. We're going to clear, delete out of our table here, and we're just going to do some math. So we'd say, okay, negative 1.07 times 48 gives me negative 51.36. plus 92.87. So when the latitude is 48 degrees, we get an estimate of the temperature would be about 41.51 degrees. And so if we check here, a latitude of 48 would be about here. So a temperature of 41 would be about here. And again, even though the temperature is lower than the temperature that comes after it, it still makes sense because, again, we're averaging data that's above and below the line of best fit.